Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Let's go.
Hey podcasters, welcome back to Making Data Simple. Al Martin here. As always, thank you for being here. If you have comments, questions, please reach out to us at almartintalksdata@gmail.com. Leave us a recommendation. We would love that. Today, I have Rishal Hurbans, who is the author of Grokking AI Algorithms. He's a solution architect at Intellect, founder at Prolific Idea. I'll give a little update on Rishal, or give a little background on Rishal in terms of a bio. Then Rishal, I'll turn it over to you because I want to hear what I may have missed. But I know you do strategic planning, ideating, designing, developing solutions for local and international clients. You founded Prolific Idea in 2015. This is where I've got to dive into more because I want to hear more about is a collaborative productivity platform that you've created, HiveMind. I know that you're building a document processing platform in Vision.tech. So that's a lot of information. Let me pause there and welcome you to the podcast. Thank you for being here. And then go to the introduction. Welcome, man.
Yeah, if I can elaborate a little bit about that. My day job's as a solutions architect, where we're kind of helping different customers in different industries solve their problems using technology. So it kind of varies based on the interaction with the customer and their context and their business domain. Whereas the other two kind of platforms that you mentioned are more kind of passion projects and side projects where myself and a bunch of friends wanted to kind of explore some of our own ideas, learn some of different kinds of technologies, and just try it out and see what works. So HiveMind is essentially a platform where it aims to represent ideas and relationships between ideas visually through kind of mind mapping and a shared canvas, and that you can work on in real time with your colleagues or friends. And Vision is an automated document processing platform. So we took advantage of some of the cool developments with cloud computing from some of the big players that kind of offer compute to process images using neural networks and other machine learning models. And the goal there is to kind of move away from paper-based forms and paper-based world to a paperless world by using this kind of platform as a transition between that.
Nice. So here's the thing. I know you're doing some fascinating stuff, and I'm sure people didn't catch on to everything that's already been mentioned. So I want to slow it down a little bit and talk about it, if you don't mind. And I do want to talk about, why don't we start with the book, because I think there's some interesting things in Grokking AI Algorithms, the book that you authored. And a lot of your book covers an approach around AI algorithms, biomimicry. And I don't even know if many of our audience knows what biomimicry is. So if you could explain that and talk about it, I find it fascinating.
Yeah, sure. Biomimicry, or kind of nature-inspired computing or nature-inspired algorithms, are computer algorithms that solve real problems that we come across. It might be business problems, it might be research problems, it might be mathematical problems. But they solve these problems by mimicking something that happens in nature. So some examples of this is you might see ants trying to find food sources and take it back to their colony. And if we have a look at a bunch of ants, if you go out into your garden or just observe them in any space, you'll notice that they create trails that they follow in kind of a line. They're not really chaotic in kind of finding their food sources. And how they do that is through dropping pheromones. And pheromones are just perfumes that smell a bit differently. So they drop pheromones everywhere they go. And what's quite interesting is that these pheromones have different kind of actions that they indicate or meaning that they indicate. So a specific perfume might mean, hey, I need help collecting some food. And other ants would pick up on that pheromone and follow it. or another pheromone might actually be used to show recognition and say, "Hey, well done for, something you accomplished to a different ant." So that's essentially how ants work and how their colonies work and how they communicate. And what I find quite fascinating is that when you look at a single ant, you don't really think of intelligence at all. But if you actually look at the colonies they create and look at how they interact, there's a lot of emergent intelligence in their interactions. So what we've done is really intelligent researchers have created algorithms that mimic the behavior of ants to solve real world problems that we might experience, like routing network traffic. You can see how that might be quite similar to routing to a shortest path to a food source.
Let me see if I can get this right. To restate, then, biomimicry is about using naturally occurring algorithms to solve complex problems so they can improve efficiency, optimization, machine learning, deep learning, AI, whatever. They're really like natural mathematical occurrences to technology, or that can be applied to technology and development. Did I get it right?
Yes, more or less. I'd say
You're
one.
pausing. You're pausing. I must have missed something.
Yeah, I'd say one change to wording. I'd say instead of
Yes.
naturally occurring math or algorithms, I'd say it's algorithms and mathematical formulas that are derived from naturally occurring phenomena. So these mechanics still work. The math not might not work out completely accurate when we see it in nature. Obviously, the natural environment is quite chaotic and changes, but the basic premise of how ants work or how bees kind of swarm to collect their pollen, those phenomena that's observed have been packaged into algorithms that we use.
All right. I get the network traffic correlation. But you got to tell me, I mean, because look, I think it's fascinating, very cool. And yeah, you're right. When you look at an ant, you don't think of intelligence. In fact, that's the last thing you'd think of. But then when you start putting it together and really consider the ant colony, it is quite fascinating, no different than bees. But how are you applying that to AI or deep learning and machine learning? How does that transition go? I mean, where do you make the crossover and how does it really help? Can you give me more on that?
Yeah, I think if we take a step back away from the kind of modern approaches right now in AI and ML, these algorithms are usually very useful in solving problems where a good solution means searching through many permutations or many combinations of possible solutions. So, if I can give an example of that, you might have heard of something like the knapsack problem, where you need to fit as many items into a bag as possible to maximize the value of the items in the bag. However, the bag has a certain capacity. Now, if you have, I don't know, 50, 100 items, you'd have to try every single combination of those items to see what would give you the best outcome. Whereas a genetic algorithm, for example, this is a different one now. It's based on the theory of evolution, still based on something that occurs in nature, that can help you accomplish or find a good solution much faster than a brute force approach. So that's the kind of problems that these algorithms solve in isolation. Genetic algorithms, the one I just mentioned, which is essentially based on DNA and reproduction. So you're a outcome of your mother and father's DNA with a bit of mutation, obviously. It uses the exact same premise. So you've got two solutions that may perform better or worse than the other, but the child of those two solutions might exhibit way different properties that might be a better solution than their parents. So that's basically the concept of genetic algorithms, and that's being used in machine learning to find good features. So if you think of a big data set with lots of different features, and we don't really have a strong understanding of each and every feature and how it relates to each and every other feature, we could use something like a genetic algorithm to find the features that are important for the problem we're trying to solve.
Well, help me out here. Part of what you're talking about is computational modeling, right? I mean, computational modeling is modeling systems after the structure of animal minds, like essentially neural networks from a nervous system or brain structure. Well, first, let me stop there. Pause for a minute. Is that accurate?
Yeah.
So here's my question on that. I mean, how do you go about doing that, number one? And two, are you doing that within your company at Prolific? What's the go-to-market? Does that make sense?
Yeah, it does. So I'd say you can't really look at these algorithms as a silver bullet to solve, a variety of problems. It's really the purpose of the book. Really, is to kind of demystify the possibilities of what could be used in different contexts. So if you're talking about something like a genetic algorithm and in document processing, if you've got a picture of a document and you've got certain interesting areas in that document, perhaps there's a logo, perhaps there's an address, perhaps there's a kind of table that contains information pertinent to that document. We probably know that those features exist because that's kind of a standard. But if you scan a document or take a picture of a document, there's always going to be variation. It's never all going to be lined up correctly. It might be skewed. There might be some shadows on the document. So, what we could do is look at different portions of it and use something like a genetic algorithm to find combinations that tell us that this is how should we rotate that document so that we can process it and extract information from it. Because if you had to try every possible kind of rotation and skewing and warping of that document, that might be computationally expensive. So these algorithms are usually aimed at giving you good solutions, but they do not promise the best solution. If you had to brute force the problem, you would come up with a good solution, but it could potentially take years to compute. Whereas what these algorithms promise is effective computation, however, not a perfect solution, but a good solution.
The thing I'm still I'm struggling with is, I mean, I think it's fascinating. And, a lot of the modeling, like whether it's computational modeling or otherwise, mimics neural networks that mimics the brain structure, et cetera. Now, like you said, you talked about applying the concepts that you see in ant colonies around network traffic. Is that a real world example? And are there other real world examples that you're driving?
Yeah, sure. So the one I mentioned where we've experimented is using a GA to find good features in data sets. So that has some usefulness. But if we're talking about some more kind of hard hitting applications of it, the network traffic example is actually something that has been tested where you kind of try to find best paths to route traffic based on the load on the network. And this has been kind of experimented with some telecommunication companies. And obviously, in these solutions, these enterprise solutions, you usually don't have one kind of algorithm or one approach that solves everything. So this might be one in a toolbox of approaches. But if I talk a little bit about another concept, perhaps that's also related to nature-inspired algorithms, which is particle swarm optimization. That has direct applications in neural networks. If you're familiar with neural networks and kind of how they're trained, you'd know
Right.
that finding weights is quite a computationally intensive task, and the weights essentially encode the intelligence of that network. And we're kind of typically using things like gradient descent to help us find that, because if we didn't, again, we'd have to search every possible combination of numbers for those weights, which is unrealistic, right? It would be computing throughout our lifetimes before it gets a solution. So gradient descent aims to help us solve that problem. Something like a particle swarm optimization algorithm also helps us with finding those weights. Essentially, what it's doing is it's finding local and global minima. So if you look at bird flocks, if they're flying towards a specific location through migrating, you'll notice that birds have a certain pattern that they fly in and certain types of behavior. So this all comes from saving energy, finding kind of the optimal air resistance, and a bunch of other factors. So that same kind of thinking has been put into an algorithm called particle swarm optimization, which uses these principles of a local best, a global best. It tries to see where the swarm is going. What's the best solution that I've found? What's the best solution that the swarm's found? And it uses that to find global minima quite quickly in comparison to other optimization algorithms such as gradient descent.
Makes perfect sense. I mean, the question is if I'm a company, I mean, are companies taking advantage of some of these optimization models for their own benefit, or is it just reserved for to essentially the study of these bee swarms, the study of bird flocks, etc.?
I'd say in the mainstream, from my perspective and from what I know, I don't think it's taken advantage of enough. I do know of some companies doing some interesting things with these algorithms. For example, there's a advertising company in the UK that's used genetic algorithms to plan what programming gets shown on linear television, right? So, what programming should happen at what time, what advertising should appear in between that program, and that's all been done using a genetic algorithm. I have a feeling that it might just be an opinion, but I think that kind of neural networks and deep learning have become the go-to thing to solve a problem without considering what else is out there, because it's such a kind of buzzword. It's out there. People want to be using it because they hear about it without really understanding what the alternatives might be. And that was actually one of the motivators for writing this book, to kind of demystify what else is out there for developers, to get them thinking about how this could potentially be applied in their potentially commercial projects or whatever work they're involved in.
I think you're right. I mean, like anything, we just know of neural networks and traditional models, and you go with what you know to solve real world problems. This is a little bit farther out, but has the opportunity to bear even more fruit and be very innovative. Do you think genetic algorithms in the future are going to take off?
Yeah, I think so. They're not anything new, right? So genetic algorithms, particle swarms, and colonies, the three concepts that we've been speaking about, are quite old. But then again, so are neural networks. Kind of neural networks have come to the forefront now because we've got more computation. We've gathered all this data with the boom of the internet, and I think organizations are seeing value in using that data, being able to compute it efficiently, and being able to make decisions rooted in data rather than rooted in kind of gut feel or opinion. So I think that's when neural networks have been quite useful. But I do think that everything has its use case. So neural networks are great at the things we're doing in the video, image, audio kind of processing side of things. When we're looking at businesses, they're usually, at least enterprise organizations, they usually have many facets within there, right? They're very large kind of mammoths. In those organizations, you're not always dealing with media. You might be dealing with a lot of number crunching or optimization or recommender systems that don't involve any video or audio. And in those instances, I think there might be opportunity to use some of these algorithms that I just mentioned for a couple reasons. So they're probably simpler to implement, simpler to test, and verify if what you're doing is actually correct. And they compute faster than neural networks and require less computing power.
Given our DNA and that our cells contain both data and state, what are your thoughts on taking everything you've been talking about, but how machine learning and AI could be used to predict, understand illness and health? Well, I'll stop there. To understand illness and health, given the DNA has, again, contains both data and state. I got to believe that we can have algorithms, genetic algorithms that can help us out there.
I was talking a little bit about genetic algorithms there, and basically that whole premise is based on DNA. So your DNA is represented as chromosomes, and those chromosomes consist of genes. So if you look at a chromosome as just being like a binary string of ones and zeros, and that chromosome is a potential solution. So maybe it's a sequence of things, and one means that you should execute on that, and zero means that you shouldn't. That's kind of a primitive explanation of what a chromosome might be. Genetic algorithms use that premise to solve problems. When we start talking about our own DNA and we mirror that to that really simple concept I just mentioned, our DNA is also represented in the same way. However, it's a little bit more complex. There's a lot more genes, there's a lot more chromosomes, and there might be a little bit more nuance in the representation of that data. But I think definitely if we look at machine learning and neural networks, the entire goal is to find patterns in data. Try to look at a sequence of DNA, for example, look at a person's medical history and potentially their family's medical history and their DNA, if you have access to that, and potentially find correlations between certain markers in the DNA and certain conditions that may occur in the family. So, a lot of these things are hereditary, and that's from your genes, or that you inherit from your parents. So, I definitely think that there's space to work with that data. The one question I might have is how we get access to that DNA data, because I know there's quite a bit of controversy around who owns DNA data. Do you actually own your DNA? If I pluck one of your hairs while we have a coffee and I sequence your data, like, is there any repercussions? So that's an interesting, I guess, legal or ethical or philosophical discussion. But I think getting access to it is one issue. But I think that if we do, there's definitely a lot of possibilities with the algorithms that we're using.
I think you just outlined the next book for Michael Crichton, or the next movie that we'll see about somebody taking somebody else's DNA. I hope it doesn't get to that point, but I think those are the challenges of our day. And yes, we've had people, like I always say, and I've said this on this podcast many times, people are worried about the Terminator. I'm worried about things like what you describe. Who's going to control DNA? What is our privacy around DNA? And each country, as we've talked about in the podcast before, each has a different approach to that. In other words, China's approach to DNA is very different than the United States, and I presume South Africa as well. So, and I don't know that the governments are really tackling this as they should. They're doing some things like GDPR and stuff like that, but look, that just scratches the surface. I don't know if you feel the same way, but I think that's the challenges we're going to have as we move forward.
Yeah, I agree. I think the issue is that technology and kind of tech advancement has been just exponential, right? There's a really cool article by Tim Urban on his blog. His blog's called Wait But Why, and he's got a really good article about tech progress and tech evolution. And he says if you take a human from 10 years ago and bring them to 2020, for example, how mind blown would they be with progress, the tech progress? So let's say if we took somebody from the 80s and brought them to 2020, that's just 20 years. That person would be pretty blown away. I mean, you've got GPS, you've got instant messaging, which wasn't available 20, 30 years ago. And then he says if you go back 20 years and pull someone 20 years into that point, so someone from the 1960s, 1980s, etc., people get less surprised by the progress. And what that highlights is that in our kind of lifetime and closer to us, there's exponential technological progress. And I think if you believe that, then if we talk about laws and governments, I think that the evolution and change in law and regulation moves far slower than the progress of technology. I can see why that happens. I mean, we're worried about protection of personal information and GDPR and all of that stuff, but we should have been looking at that with the internet boom, right? 20 years ago. We shouldn't be looking at that now. So I think it's just a mismatch of pace between tech and law.
So, Rishal, is there anything that you want to comment on or that we haven't said about in your book?
No, I think we covered kind of most of it. To be clear, the book is more than just kind of nature inspired algorithms.
Mm-hmm.
It kind of starts off with classic search to kind of create a baseline of how we solve problems. Then it goes into some of the nature inspired algorithms. And then we actually get into machine learning, artificial neural networks, and reinforcement learning. It's really meant to be a book that demystifies these different concepts and shows you how it's applicable to different problems. I also hand illustrated everything, so it's a very visual book, and it's intended for kind of those that aren't really math champions. Like I'm not necessarily a math champion. More of a visual learner, and that was kind of the intention.
So two questions on that. One, you did all the visuals yourself?
Yeah. I sketched all of that on my drawing tablet.
Did so? Where can you get this book on Amazon?
Yes, it will be on Amazon in the next few months. It's currently in early access on Manning Publications website. I think it's manning.com.
Manning.com. How what's your experience or history that led you to be the expert with a lot of these concepts? I mean, that's pretty in depth data science or AI algorithms we've been talking here today. I mean, so what's your history that gave you that expertise?
Okay, firstly, I hate being called an expert. I don't think anyone's an expert. I think everyone has something to learn, and I prefer kind of being humble in knowing that I don't know everything. But to answer your question, when I was studying at university, as I mentioned, I wasn't the greatest at maths. I just couldn't understand why those theorems and theories existed. What was the practical applications of them? And when I started learning more about AI algorithms and computation, I actually was blown away that the simple theorem that we learned back at the start of university actually solved big problems in a real way. And after speaking to a lot of people that I work with, I also do a lot of talks and attend a lot of conferences with developers. I realize that there is a little bit of fear around the math, and that's what kind of steers people away from trying to learn these concepts. And personally, I think using metaphors and using visual communication is a better tool to teach those concepts, and that's kind of what brought me to writing this. I've given quite a few talks about these concepts, and I got approached by Manning Publications, and they asked me if I'm keen to put this in a book format, and kind of here we are.
Well, very nice. So how do you learn? What's your secret?
Yeah, that's an interesting question. Yeah, there's different formats. So while I'm driving, I listen to a lot of podcasts. Kind of spend the time in traffic, kind of learning. And I believe even if you listen to a 30-minute or 60-minute podcast, if you can get one idea out of that, it's better than getting nothing in that commute, right? I try to read different types of books. Some might be technical books. Some might be more on the business side of things, or psychology or philosophy. Yeah, if we talk more technical, I think application of a concept is what helps me learn the best. So if I could do a little tutorial, or actually code something or solve a problem using a concept, that's where you learn best, as opposed to reading an article about it and then assuming that you know how it works.
What are some of the best podcasts that you'd recommend?
Yeah, so some that I listen to, one that's really great with the diversity of topics is TED Radio Hour.
Hmm.
At first, I was a bit skeptical. I thought they're just streaming the audio from the talks, but they actually made this really cool format where they bring in the speaker and they discuss that topic. And it ranges from tech to psychology to kind of society and how we're working, people's research. It's quite an interesting one. I find another one that kind of opens your head up to, I guess, being a little bit more empathetic towards people, thinking a bit more critically about how you work, what your goals are, what your purpose is a podcast called Hidden Brain. That's also one of my favorites. And then I'd say the third one is a business or tech business focused podcast called Masters of Scale. It's hosted by Reid Hoffman, who founded LinkedIn, and he basically interviews people from all of these big tech giants, or sometimes small startups that have become unicorns, and finds out what their secret was.
We will put those in the show notes, and I've got them down here because I will take a listen myself. Thank you for that. Hey, thank you, Rishal, so much for being here. Before we close, where can listeners go to learn more about you or what you're working on?
Yeah, I think the easiest go to my website. Links to everything else is there, and that's just rhurbans.com.
All right, fantastic. We'll also put that in the show notes. Thanks again. I appreciate you being on. Very insightful. A completely different look on AI than we've had here before. So greatly appreciated.
Thanks for having me.
Hey, for you listeners, as I always say, please reach out to almartintalksdata@gmail.com. We'd love to hear back from you. We love any reviews that you would provide. And until next time, I'll see you on the podcast. Thank you so much for listening.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit ibmbigdatahub.com/podcast to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests, and do not necessarily represent the views of IBM. Until next time,
Let's go.
over and out.
Go.